Now we have an Xcm demo from Parity Technologies. That's an apostrophe S. I pronounced that really funny. But from Steve Degosserie from Parity Technologies. You good to go? Cool. Take it away.
Thank you. Can everyone hear me? Yeah, awesome. Cool. So, how is everyone? I think I'm catching you just after lunchtime. So, some of you might have a little nap. That's okay. So I'm going to talk about I'm going to show you some Xcm demo. So you probably heard a lot about Xcm these days and for a while. And I wanted, oops. Hello, hello. Hello, hello. Okay, good. And I wanted to do a presentation that makes Xcm a bit more approachable and tangible. So what I'm going to do is show you how to create and send some Xcm messages using mostly Polkadot.js. So there will be no programming involved. But this will also be a bit more tangible than the theory and high-level explanation that you've also heard. My name is Steve. I'm a senior solution engineer at Parity. This is the agenda. So first we'll have a high-level overview of what is Xcm and what is the setup that I'm using on my machine as a playground to make those demos. Then I will show you asset teleport operation, and then two reserve-based transfers. And I will introduce a lot of terminology, explain you a little bit about all the concepts that are involved. And then we'll do a little recap of what we've learned and what we can look forward to, specifically Xcm v3 that's coming very soon, and that's very exciting. All right. So first things first, Xcm is a cross-consensus message format. So it is not related to XML. Unfortunately, some of you might be disappointed, but this is what it is. And it aims at being a very generic and extensible language to express some operations to be performed on assets in different consensus environments. It's a bit like REST is related to RESTful, where REST is an architectural set of rules and principles. It's a bit the same with Xcm. So it is not a protocol, it's a message format. That's really important to understand. And it allows to describe messages and operation with very meaningful content. You will also hear, however, about XCMP and other protocols that are aimed at transporting Xcm messages across different technologies. So Polkadot actually implements several cross-consensus protocols, and there are two families, we will say. We have vertical message passing protocols. So if you think about the relay chain and parachains, and the relay chain is positioned on top, then we have downward message passing. That is when Xcm messages are sent from the relay chain to a parachain. And we have upward message passing when a parachain sends a message to the relay chain. We have another category of transport protocols called horizontal message passing, typically to go from parachain to parachain. And obviously you've heard about XCMP. This is basically the end game for Xcm, where parachains will be able to exchange messages directly between themselves in a peer-to-peer manner and trustless manner. But XCMP is still in the works. So meanwhile, we have an intermediary protocol called HRMP, HRMP for horizontal relay routed protocol, which means that the Xcm messages are actually going via the relay chain and are routed to between parachains. So this protocol is live right now, but it will be deprecated when XCMP goes live. Xcm is also a language that has good versioning, so it has to be future-proof and forward compatible. So we need to have proper versioning in that language. A little bit of history about the version. There were first like first initial version V0 and V1 that were not really production ready. The current version that is live on Kusama and Polkadot is version 2. So this presentation will focus on that version. And we have Xcm v3 coming. That's a very exciting new version that adds some support for non-fungible assets. There's some improved mechanism for fee handling, and also the ability to transport messages across bridges. A few more concepts and a bit of terminology before I jump to the demo. Like this is the demo or the interesting part of the presentation. If you don't know, parachain are identified by a unique identifier. So in the context of this demo, I have 3 parachains. There's StateMine with ID 1000, Trappist with ID 2000, and a blank parachain template with ID 3000. Xcm has, as a language, has some language constructs that allows to express locations. So it has to be rather abstract because we want it to be future-proof. So we have something called universal consensus location identifiers. And with that, we can express locations like a certain parachain or a certain account or a specific module in a runtime. And this is all done in a way that is very similar to how we express file path in a file system. So it's hierarchical. So this is just like for your general understanding. I will not go very deep in that because I want to show you high-level demos. But know that we have some language construct for locations and also for assets. Obviously, a big focus of Xcm is to perform operations on assets, digital assets, whether they are fungible, non-fungible. And we also have a part of the specification that is focused on that, and it's called Universal Asset Identifiers. Now, a little bit about the setup that I'm using for those demo. I will basically be using the Rococo relay chain running on my laptop and 3 parachains. So there is StateMine. StateMine is what we call a common good chain. So this is a chain that has, it's a little bit special in the ecosystem. It didn't have to go through a crowd loan to acquire a parachain slot. And it's used as a reserve for assets, fungible assets and non-fungible assets. And it also has like a very special relationship with the relay chain it is connected to. I will explain that a little bit after. Then we have a parachain called Trappist that is just a test parachain for education and learning, and it comes packed with a lot of features, assets, some governance and other things. And then on top of that we have like a blank parachain template just used for some operations that I will show. Now the lines that you see here between the parachain, the dotted lines, they actually represent the channels that have been pre-configured between those parachains. But this is like a conceptual representation because HRMP channels are actually unidirectional. So to have like bidirectional communication between parachains, we need to configure 2 unidirectional channels. And this is all pre-configured in the setup that I'm using. As I mentioned, we have Rococo, that's the relay chain. It provides shared security for the parachains that are connected to it. It provides interoperability, so it will allow parachains to send each other Xcm messages. It also has some governance features. StateMine, as I said, is acting as the asset reserve for this whole environment. And it actually has a trust relationship with the relay chain in a sense that the relay chain will trust StateMine for a certain type of operation that we call asset teleports. And also StateMine doesn't have its own native token. It's using the same native token as the relay chain. And finally, it is considered as the asset reserve for for Rococo and for the other parachains that are connected to the relay chain. And then we have Trappist, as I said, is fully featured. We have assets, we have WASM contracts, we have some governance, some identity. And this is just, there's no custom code in there, basically. It's just using some module from the frame library, the palettes from the frame library. So this example, you can actually achieve it using the standard palettes that we have in frame. All right, so the first demo that I will show you is a teleport operation. I will teleport some asset from the relay chain to state mine, the asset reserve. The context that I've prepared, well, actually I haven't prepared it. So I will do it live, so maybe this will be useful for some of you. So what I'm going to do, no, that's for after. So what I'm going to do is I'm going to transfer some of the native token from Alice's account on the relay chain to Alice's account on state mine. And for that, I will use Polkadot.js, and I will use a specific instruction of the Xcm palette. This little diagram shows you what we want to achieve from a conceptual perspective. What actually happens when we do an asset teleport is that there is an intermediary account that is used on Rococo, and we called it a sovereign account. So this is a concept that is a bit similar to reserve banking. So what actually happens is that the native token will be moved from Alice account to the specific account. It's not a sovereign account, sorry, it's the teleport checking account. That account is a bit special. It will track all the teleport operations that are done across all parachains, and it will just rely on the fact that the parachains that support teleport operation are doing proper accounting. On state mine, then, the other part of the operation, we will actually have the tokens that will be minted into the beneficiary account. All right, that's a little bit abstract. I will show you now with Polkadot.js how it works. So I'm switching here to the other part. Actually, I have 4 tabs open because we have the relay chain in 3 parachains, and I have Polkadot.js UI open for each of those chains. All right? So to perform this asset teleport operation, I will use the, where is it? Xcm palette. But actually, I've already prepared all the messages. So what I can do is I can take a call that's encoded, directly copy-paste it into Polkadot.js, decode it, and explain you what's going to happen. So I'm using the limited teleport asset extrinsic from the Xcm palette on Rococo, and I'm passing some arguments. First, I specify what is the destination parachain. So I want to do the teleport operation between Rococo and state mine, so the destination parachain is parachain 1000. Then I need to specify the beneficiary account of the funds, and that is in the context of the receiving chain. So I basically mention the address of Alice on state mine. And then the last part is I need to specify what is the asset that is being teleported. And the asset is identified by a location, which is here. I am on Rococo. And I want to transfer 1,000 units of that asset. The asset on Rococo has 12 decimals, so that is why we have a very long number. Finally, we have to specify which asset will be used for paying the fees for executing the Xcm messages. All right, so I will submit the transaction. So what I'm going to do is I'm going to now try to spot the events that have been generated on Rococo and on state mine. All right. Let's see if I can find it. Can you see the screen actually? Yeah, it's big enough. All right. So I will backtrack a bit. I need to. Okay, here it is. So this is the extrinsic that I sent. As I explained you on my little diagram, we can see that some funds was withdrawn from Alice's account. We can see that a new account was created. This is the teleport checking account. And then we can see that a certain amount was deposited in that new account. All right. So what I can do is I can also go here in the address book where I already added that account. So the fund was moved from Alice's account to the teleport checking account on the relay chain. And now if I go on state mine, I will also try to spot the events that were generated. They should be there a little bit earlier. There you go. Okay, so now it's interesting to see that we have a downward message that was received using DMP, and it's not the one I want. And we have some amounts that was deposited into Alice's account. All right. So if I now check the balance of Alice's account, well, we can see I have 1,000 plus what was already there. The total balance of the token, the native token on chain, was increased. And going back to Rococo, I can see that the balance of Alice was decreased. So this is what we call an asset teleport, and it's, as I said, it's a bit special because there must be a trust relationship between the relay chain and the parachain, between that operation. For which that operation will happen. And you have also seen this special teleport checking account that we are using internally for that operation to work. Okay. Now, a more interesting type of operation is what we call a reserve-based transfer. And for that, I will actually need to do a little bit of configuration, and I hope this can be useful to you. So what I'm going to do is I'm going to create on StateMine a fungible asset that I will call XUSD. It's a fictitious, it's a stable coin. I'm not going to call it UST or something like that. And I will mint 1 million units of that token on StateMine. And then I will do something, I will mark that asset as sufficient. And what that means is that an asset that is sufficient on StateMine means that accounts can exist holding only a balance of that account, and they don't need to also hold some balance of the native token. And that will allow us to do some very interesting things like paying for fees for cross-consensus operation, and paying the fees with the custom asset that we have. And we will not have to also add some native token in the operation. On the receiving end, on Trappist, what I'm going to do is I will create a derived asset called TXUSD that will be fully backed by the real asset on StateMine, so XUSD. And the asset palette on Trappist will be used to track balance of local accounts. And it's very important, obviously, that that derived asset on the parachain, we do not emit any quantity. We do not mint quantity manually. There's only a mint and burn operation based on Xcm operations that are happening. All right. So this is what we're going to do. This is a reserve-based transfer. Again, this is from a conceptual perspective. What's going to happen? Effectively, what will happen is that on StateMine, the amount of transferred XUSD will go from Bob's account to a special account that we call a sovereign account. And the sovereign account is an account for the parachain on StateMine that will hold some money in reserve while the derived asset is being tracked on the parachain. Does that make sense? So there's a lot of new concept, a lot of terminology, but this is how we do transfer across different chains using a chain as asset reserve. All right, now for the demo. As I said, I haven't prepared the setup in advance, so what I will basically create the asset and you will see how it works. So I just go in the asset tab here in Polkadot.js. I will create a new asset on StateMine called XUSD with 12 decimals and a minimum balance of 1 milli. It will have the ID 1. All right. So while that is being done, I will go to Trappist and I will create the derived asset that I call TXUSD with basically the same setup. All right. There you go. So now on StateMine, I have my fungible asset called XUSD. I need to mark it as sufficient so that fees can be paid in that asset. To mark it as sufficient, I need to do like a call that is a little bit special. It's a pseudo, it's like a privilege operation to change an asset from not sufficient to sufficient. StateMine doesn't have its own governance body. It actually relies on the relay chain's governance body. So what I'm going to do is I'm going to send a message from the relay chain to StateMine to say, mark this asset as sufficient. I'm going to do that as a pseudo operation on the relay chain, but this is something that already happened for real. I mean, recently there was, I think, remark on StateMine that was marked as sufficient, and that was a decision from the governance body on the relay chain. So for this, I will use another extrinsic from this little helper palette that we have. So what I'm going to do is I'm going to queue a downward Xcm message from the relay chain to StateMine. Destination, yes, is StateMine. What I want to do is a Xcm transact operation, which basically means it's an arbitrary extrinsic call. And on the destination chain, StateMine, this will be acting as, the origin will be acting as super user. And I have prepared the call here. The call is basically calling into the asset palette and forcing the asset to be sufficient. All right. Oops. Bad origin. Oh yeah. I need to go in the pseudo module. Pseudo wrapper. All right. There we go. All right. So if I check the events here, I can see that my asset status was changed, so it means it is now sufficient. So I will mint 1 million of it to Alice's account. So now I'm on StateMine, and I will do the reserve-based transfer operation from StateMine to the Trappist parachain. So this is an operation from a parachain to another parachain. All right, now Alice has 1 million XUSD. I will just send some to Bob, and I'm still on state mine. All right, Bob should have some. So I have my XUSD sufficient fungible asset on state mine. On Trappist, I have the derived asset. There is no quantity that was minted, so the total balance for that asset is 0. And I will now send the extrinsic. That will do a reserve-based transfer. I will copy it here. All right. And this is obviously Bob that will send some quantity of the XUSD token from its account on StateMine to its account on Trappist. So the destination parachain is Trappist, parachain 2000. The beneficiary account is Bob on Trappist. And then we specify what is the asset that is involved in the reserve-based transfer operation. And we have something a little bit special here. I have created a custom asset in the asset palette, and Xcm allows me to refer to assets in modules of the runtime. So what I'm actually specifying here is I want to refer to the palette instance with ID 50. This is actually the asset palette in my runtime. And I want to refer to the asset with ID 1. And this is basically XUSD. I'm just spotting some little decoding issue here, so I need to refresh. Otherwise, it's not going to work. All right. And I want to transfer 5,000 XUSD. Bob has 10,000. All right, so we trigger the reserve-based transfer. So what I'm going to do is obviously try to spot the events that are generated. So there you go. So we have the limited reserve transfer asset. That is not the one I want. So as I showed you before on the little diagram, we actually have 5,000 XUSD that are moved from Bob's account to the sovereign account for Trappist on StateMine. And I can verify that here. Unfortunately, in the asset module in Polkadot.js, we cannot see directly the balance for accounts that are not well known. So what we have to do is to go check the chain state here. So what I can do here is look at consult the chain storage for asset ID 1 and the sovereign account, and indeed I have 5,000 there. And then on the destination chain on Trappist, I also want to spot the events. Here it is. I can see that some assets were issued to Bob's account. So if I now go to, and now I am on Trappist, the receiving chain. If I now check the assets and I look at the balance, Bob has 5,000 TXUSD. This is the derived asset that is backed by the real asset on the asset reserve chain. And I have a little bit less than 5,000 because some fees had to be paid for the execution, all right? So just going back to this, the funds are moved on the asset reserve to the sovereign account of the parachain, and on the receiving parachain, the derived asset is minted into the destination account, all right? Cool, my demos are working. Pretty happy about that. Thank you. All right, now for something even a little bit more complex. We will have a reserve-based transfer going from one parachain to another parachain with StateMine as the asset reserve. And so Bob now has 5,000 TXUSD on Trappist. I will send 3,000 to Bob's account on another parachain, and still using StateMine as the asset reserve. So what I'm going to do is create an additional derived asset on the receiving parachain. And effectively what will happen is a fund movement between two sovereign accounts on state mine. And on the originating chain, the asset will be burned, and on the destination chain, the derived asset will be minted. Demo. And obviously I need to copy this, because if I have to create it manually, you'll get bored. So, Trappist. Oh, first I have to do something. I haven't created the other derived asset on the target parachain. So, let's create it. PXUSD, PXUSD. All right. There we go. So, it should be ready. Good. So I go back to Trappist. So I'm showing you the diagram again. I'm starting from the parachain Trappist, and we will send some amount using a reserve-based transfer operation with state mine as the asset reserve. So I will decode my prepared operation. Let me see if anything. Okay. And here I'm not using any kind of extrinsic that makes it easy for sending those teleport or reserve-based transfer operation. I actually do an execute, and I have to provide the full XCM message. So if we have a bit of time, we can actually look at what's happening. Sending account will be Bob. And this is where you will see the power and flexibility of XCM, where we will have like a tree of instruction that will be executed in different consensus environments. So I'm starting from Trappist. The first instruction that I'm preparing is withdrawing assets from Bob's account. And I need to specify which asset. This is the asset with ID 1 in runtime module with ID 50 on parachain 1000. So I am on Trappist, and I'm referring to the asset that is on state mine, okay? I will transfer a certain quantity. Then I will initiate a reserve withdraw on state mine, and I will specify the destination for that operation to be, the reserve parachain is state mine, so this is parachain 1000. Then when I am on state mine, I need to buy execution time for that XCM message to be executed on state mine. So this is why we use the buy execution instruction. Again, I'm referring to the asset with ID 1 in pallet 50 on state mine.
Hey Steve, sorry, we have to wrap it up. We have another guy in waiting. Well, let's give a round of applause for Steve.
Okay. Thank you.
No worries, it's very cool.
Hello. Can I just maybe show the key learnings and close the presentation?
Yeah, okay.
1 minute.
Wrap it up, take it home, land the plane.
Thank you. So I just wanted to wrap up with the fact that XCM is a cross-consensus message format. It's future-proof, forward-compatible conversions. V2, V3 is coming, super exciting. And V3 will allow operation on NFTs, XCM messages to be sent across bridges, and also super exciting interactions with smart contracts. Thank you.
Thank you so much.